Gravitation. This is the name of this lecture. In details, I will share all information regarding this with you, and I will feel better when I discuss. I feel better when I discuss my lectures with you. Uh, but lecture should make sense. Okay, then it will be useful for me and as well as for you. Uh, so today in this lecture, name of this lecture is what? Gravitation. I will try to make sense it. I will I will convert it into valuable for you. So in this slide, now some important points, important points that we need to follow during this lecture. I want to share with you. First, we will not go too much out of context of our lecture. Okay, if we do like that, then of course we will go out of context. When we will go out of context, it means we are not connected. We are not connected with our lecture. Our focus is on somewhere. So first point is that our focus will be on slide, on discussion of this slide. Whatever is mentioned in this slide related to points, we will discuss all points related to all those points which are mentioned in this slide. There are a lot of slides, but in front of you, whatever is a slide, that slide we will explore. Clear? And second word, if I am I yes one thing second point, this is the second point. Whatever I am teaching you, whatever I am explaining, I will be explaining with examples. Sometimes I can ignore, but many times I will take examples so that our explanation can be clear, whatever we are understanding. Clear? So examples we will take. As much as we will take examples during the lecture, then it will be useful for us. Okay, that's why we have understood what uh, a definition. Then now we need to understand what example related to that definition. So that is what we will do. Now, after completing one slide, we will move to the towards slide. Clear? Clear? Our focus will be on the discussion, not this, not that. Okay, whatever we will include examples should make sense. Clear? Okay, what else? Whatever we are taking time for this lecture, so this time should convert into valuable. How much? Whatever you taking time, it doesn't matter. But if you take time too much but you are not providing valuable, means I am not providing valuable, I am taking too much time, I am not providing valuable, it means it is not useful for you. And that is what we will not do. We will not do like this. So this is also important point, that we can take more time, but that time should be what valuable. That time should be valuable. Okay. Now let's start. If I left some point, then uh, later we will. I will tell you. Uh, Later we will see. Now in this slide, now we are going to follow. In this slide, we need to understand what is name of this lecture. So as you can see, name of this lecture is what? Gravitation. Standard, this is a standard. Standard is what? Ninth class. And it's me. This person, who is this person? It's me. And now about it, our focus will be on this discussion, and whatever points will come from this discussion we will discuss, because those points will be connected with this discussion. That's why, for example, Beyonce, upward force, downward force, so all these points are connected with this. That's why it will be important to understand it. So name of this lecture is what? Gravitation. Here a little view for you. You can understand, you can observe that yes, this is a discussion. This is the object. The name of this object is moon, and name of this object is earth, and both are. It is showing that it is this earth is attracting this moon, and this moon is attracting this earth. So all this we will understand one by one. So let's start. So standard is what? Which is standard? Ninth standard. Name of this lecture is. Look, standard will not matter. We are not understanding it for examination. We are understanding for our knowledge, for better knowledge. We need to understand it so that we can apply what we can apply it in our experiment. We can take it as a knowledge so that in future we can do confidently with this whatever we want to do. Okay, so I want to say that standard in this lecture, standard will not matter. Whatever we are taking knowledge will matter. Clear? So now I am moving. So we are beginning with the introduction to gravitation. We are beginning with the introduction to gravitation. Clear? Now, whenever you hear, whenever you listen gravitation word, so remember, it is a force. As we understand frictional force, magnetic force, it is also force. It will come forth. But what's the difference between a magnetic force and a gravitational force? Frictional force and gravitational force. What's the difference? So difference is what? If force, uh, with example, I would like to tell you a object which is coming from upward, from a sky. Okay, so that object will fall to downward. So this here, what force is being applied? What force? So this view we call it as a gravitation. Any object which is coming upward and it is falling downward will be known as gravitational force. Okay, gravitational force. Clear? In details, we will understand about it. So first point, you understood that it is a force. And which type of force? The object will be coming from upward. It will be falling downward. This force will be known as. We will say that it is coming downward because of the gravitational force. Because of the gravitational force, we name it as a gravitation force. Clear? Now, gravitation is the force by which every object in the universe attracts every other object. Okay. Till now we were saying that we were understanding meaning of a gravitation from our language. But now from this language, it is telling you every object, whatever objects you are observing surrounding you, all those objects will attract to each other. There are four objects. Let's assume in front of you there are six objects. There can be a lot of objects. So some objects, okay, some objects. These objects will attract to this object, and this object will attract to this object, and it is happening. We are not able to observe. Yes, I know. It is invisible. It is invisible. I am here. I am as an object, and this wall, this device, in front of me there is a book. So book is attracting to me. I am also attracting to book, and this attraction force is a gravitational force. This attraction force is gravitational force. Did you understand? Okay. So remember, every any objects is attracting to other objects, and other object is also attracting to another object. This is happening. It is a continuum. It is a continuum from decent time, and it will be continue. Clear? Okay. I said you it is invisible. Now we cannot see that is where is it where is this object attracting to me. I am not getting attracted. How can we see? Now look, very less force with very less force, all objects are attracting to each other with a very less force, and we will see that much force. That force we will see in numericals, in mathematics. So here I am saying every object is attracted to each other with very less force. That's why we cannot see at all gravitational force acting on the objects. Clear? Now, did you believe that yes, all objects are attracting to each other? Now, I know. Again and again, I am saying all these objects are attracting to each other. It is a universal truth. It is a continue. It will be continue. It is happening right now with us. We are not able to see. I can understand your feelings. It is invisible force. Magnetic force is also invisible, and when we will come to a magnetic force, then we will be able to see that yes, objects are being attracted by a magnet. But in the case of a gravitational force, we cannot see directly gravitational force. Clear? If objects are at earth, then we will not be able to see gravitation. If there are some objects which are at earth, and there are some objects which are coming from upward, then we can observe that yes, it is a gravitational force. Clear? Now this is clear, I think. Next is, it is a universal force and acts between two masses. It is universal force. Okay. Acts between any two masses. Yes, two masses will attract to each other, and other object will attract to another object. Now here I said you with a very less force, objects are being attracted. Objects will not be gravitational Force does not say that I will repel the object. No, it is not. It is not being said by gravitation. Gravitation says that I will attract only. Objects will be attracted by other objects. So gravitation is only attraction force. Clear? It attracts with a very less force. Clear? Okay. Here it is a universal force and it acts between two masses. Okay. Till here it is clear. This was introduction to gravitation. I am moving forward. Now let's see what is it. Newton's law of universal gravitation. Let's see what is the role of Newton's law in this case. What is the role of Newton's law in this case? In case of universal gravitation. If something is being attracted, it means there will be motion. And something is being attracted, it means force was applied. That's why. So here of course Newton will come. Newton's law will come. So here what is the Newton's law of universal gravitation? It will be something else but similar. Formula is Newton's law formula is what? F is equal to G into m1 into m2 upon r square. Now what is m? M is a force. To calculate force in the case of universal gravitation, we will apply this formula. Now G is gravitation, it is a constant. This G is a constant. A1 it is a mass of one object, and second is mass of another object, and R will be distance between these two objects. R will be distance between these two objects. Clear? Distance will matter. We will take two objects because two objects gravitational force acts between two objects. We can calculate with how much force this two objects are attracting to each other. With this formula we can calculate. Okay, we will have a exact number, exact force in a math. Now here it is telling you F is a gravitational force. Yes, force gravitation. Here we are understanding in the context of gravitation. That's why here, rather than saying direct force, we will say gravitational force. Okay. J is a universal gravitational constant. I said you it is a constant, and here 6.6. This is a weakest force. It is a weakest force. I was saying that I will tell you. So this is what I wanted to tell you. This is weakest force, and it is in a negative manner. So you can think it will be more less force. Of course, that's why it is said that gravitational force is the weakest force, very less force. So J is universal gravitational constant, remember, and in a number this is in number. M1 and M2 are is equal to masses of two objects. What is the mass of one object? What is the mass of another? R will be distance between their centers. We will measure distance from the center of one object till the center of the another object. This is how we will measure. Don't measure like this. This is one, start from this circumference. Don't start from this circumference and don't end till the circumference of the other object. No, it is a wrong method. It is a wrong way. I would not say method, wrong way. It is wrong. You will have to start from the center of the one object till the center of the another object. Clear? This is the correct way to find the distance. Clear? To measure distance of between two objects. So always start from the center of the first mass till the center of another mass. So here this is formula to find what gravitational force. If you want to find mass of a first object, then from this formula you can find. If you want to find uh, if you want to find the distance, if a force is given, then from this formula you can calculate. So right now I am moving. We don't have numericals, just we need to understand what is a formula, how to calculate a gravitational force. So this is formula. With this formula everyone can find with how much force objects are attracting to each other. Clear? F is a gravitational force, J is a universal gravitational constant, and m1 and m2 are masses, and r is a distance. We will measure distance from the center till the another center. Clear? I am on. Now we have what importance of gravitation. Let's see what are important. What is the importance? Keeps planets in orbit around the sun. It is the power of gravitation. It is the power of gravity. We said that anything which is upward will fall downward. But why is it not happening with sun, with the planets? Why is it not happening? I know it is exceptional, I can say, but I don't know about it. Later, if I will have information regarding this, then I will tell you why reason behind it. So it is telling you, first sentence is telling you planets which are surrounding sun, it is not falling because of the gravitation. Who is saying this? This is saying this is the importance of gravitation. Causes objects to fall to the ground. Yes, except planets. We in the earth, I can say whatever is upward, whatever object is upward will fall downward because of gravitation. It will happen because of gravity. Responsible for tides due to moon's gravity. I don't know about it. I will explain it later. This was importance of gravitation. Now again I would like to repeat all planets which are surrounding to each other, because of gravitation force. Clear? Now any object which is upward will fall downward because of gravitation. Now free fall, it is important to understand it. What is a free fall? Each topic is important. Free fall, what is a free fall? Look, when an object falls under the influence of gravity alone. Yes. A object comes upward, goes downward. Now we would say this object is free fall. But here it is under gravity. It is under of gravity. That's why we are saying it is a what? This object is falling downward. It is gravitational force. Can we say that it is in under of gravity? Of course, it is happening because of gravitation. So any object which is coming any object which is coming downward will be in gravity, will be in category of gravity. Acceleration due to gravity, it will be represented as, this will be represented as g. On earth g is how much? 9.8 meter per second. All objects fall with the same acceleration, ignoring air resistance. If there is no air, if there is no air in in the sky, then what will happen? Acceleration will be constant. Objects will be falling with the same acceleration, with the same acceleration. But in reality, what is there? Air. What is the work of air? Work of air is to resist. Work of air is to stop the object which is coming upward. And here acceleration of this object change. Sometimes it decrease, sometimes it increase. No. It will be increasing. If object is coming upward, then it will be increasing. It will be increasing slowly. At the earth, just below, just upward to the ground, here velocity will be more. Velocity of object will be more. It happens. So here air, you will observe that air is stopping the object which is coming upward. It happens. Clear? So remember, if there is if a object is coming upward and there is no air, then acceleration will be same. If there is air in a sky, then what will happen? A speed will be increasing. Velocity will be increasing. And at the top, just above the earth, here velocity will be more. And now one point more I would like to add here. If height will be matter. If you want to see more impact of an object with another object which is at earth, then here height will matter. How? Do you want to say? Let's assume you are following a bottle in which water is filled. Okay, you are falling from the building. What will happen? Impact of bottle will be more. But if you do same, but height is less, very less, then what will happen? Impact of bottle will be less. This is what will happen. So that's why height will matter. Height will matter in the case of gravitational force. Clear? If height is more, then impact will be more. If height is less, then impact will be less. Clear? Shall we move? Let's move. Equations of motion for free fall. Yes, I think it came from acceleration. To find out V, this is formula, V plus gt. V is final position, final velocity, U is initial velocity, G is gravitational, and T is time. Same here. G, U plus T. I think G should not be here. T is the time, H is the height, 2H. Here G will come because of we are in gravitational lecture, that's why G will come here. To find out V, this formula. To find out h, this formula. To find out v r square, this formula. U is the initial velocity, v is the final velocity, t is the time, and h is the height. Time will come because if there is a motion, then time will be covered. H will be matter because, so I told you why will it matter. Of course, if we are understanding free fall, if we are understanding gravitational, so here what will happen? Object will fall from height. Okay. Now we are able to observe motion. That's why time is compulsory. So in initial velocity, where we drop object, here what is the velocity of this object? Of course 0. Now final velocity just above the ground, what is the velocity? So we will take this, and this distance was covered with how much time, and what was this height? Okay, that is how we visualize. Now mass vs weight. Oh, okay. Here we will understand what's the difference between mass and weight. It seems sometimes that both are same, but a little there is a difference between them. Uh, Mass vs. So remember, property mass weight. Definition: amount of matter, force due to gravity. Weight. Mass will tell you amount of matter, amount of object, mass. What is the amount of this object? 2 kg, 3 kg, 4 kg, 5 kg. Okay, it will come in gram. So whatever we say gram, kilogram, so it will tell you amount of matter. Now what about weight? But whenever we want to know weight, then we use a device to measure our weight. So here what happens with that device? We go and we use that device, then we will be on the device. That device will measure our weight. So it will happen that object will measure our weight because of we are applying force. Our object is applying force downward. That's why you will get weight of your okay. Here you will get weight, but in the case of mass, you find yes this much kg, this much gram. Clear? Now unit kg. Okay, and for weight Newton. With how much force you are applying force, with how much Newton you are applying force, so from weight you will get constant. Yes, it will be constant, and it changes with the gravity. It will be changing sometime. Measured by beam balance, sparing balance. Weight formula is what? M multiple G. M is the mass, J is the gravitation. For weight, we have what? M multiple G. We will take mass, whatever we are measuring, and of course gravitation we will take because of weight of object will be possible when gravitation will come into picture. Now next we have thrust and pressure. What is thrust, pressure? Both will seem similar, but no, something will be different. Thrust, it is a perpendicular force. I can say here, force acting perpendicular to a surface. surface of any object, and now I am applying like this. So of course perpendicular, this object is applying perpendicular force, perpendicular, you can say upward force, not downward force, but it should be perpendicular, and this is known as thrust. Clear? Force acting perpendicular to the surface is a thrust. What about the pressure? It will take area. It will take area. If area is less, what will happen? If area is more, so pressure will be more. If area is more and force is more, then of course pressure will be more. Pressure will be more. So in the case when it will come to pressure, then area will come. But when thrust will come, then perpendicular force. It is a perpendicular. Clear? So area is more, pressure will be more. I think pressure would be less. Later we will see. Later we will see. Unit for pressure is what? Pascal. Okay. In details, someday I will explain about pressure, because it is I am feeling interesting for this. For now, so here in this we needed to understand what's the difference between thrust and pressure. Are they same or not? So they are not same. Some points are similar between them, but some points are not similar between them. This is a perpendicular force. Thrust is a perpendicular force. Pressure is also perpendicular force, but it will take area. It will take area. Clear? Now, Buoyancy and Archimedes principle. I am not going to ignore it at all. I am not going to ignore at all. First of all, let's understand what is a buoyancy. What is a buoyancy? Buoyancy is also force. Buoyancy is also force, but it will happen in liquid water. It will happen with liquid material. Buoyancy. I said buoyancy. It means we can say buoyancy is what? It is a force, but it is an upward force. It is an upward force. Buoyancy is an upward force. Gravitation is a downward force, but buoyancy is an upward force. Buoyancy is an upward force. Here you can see buoyancy, upward force exerted by a fluid. You will observe buoyancy. It will be better to observe buoyancy in fluid material. Clear? So in one sentence you can understand it is a upward force. Gravitation is a downward force, and both will come into discussion of gravitation. Clear? So downward force, upward force, both will be applying with the same force. Both will be applying same amount of force. Okay, same amount of force. Clear? Archimedes principle. A body submerged in fluid experiences an upward force equal to the weight of the displaced force. Now I can explain it better. It is telling you, in a beaker there are water. Okay, in a beaker water is full filled. Now we take a object. Okay, we take a object which density is more. Let's say this. Okay, not that is. I have this bottle. In a beaker, we are going to sink this bottle. Now what will happen? You will observe that water is coming out from the beaker, because of when we tried to sink this bottle in beaker, then some waters came out from the beaker. Now here Here this example is trying to say that density of water came density of water which came out from the beaker will be equal to this will be equal to this density. Clear? Will be equal to this density. Water which came out will be equal to this water. Are you understanding? Are you understanding? It will happen with the all objects. If you sink any object, then some water will come, and here object will take over that area which that water was covering was uh, covering area, but now it replaced this object replaced area with themselves. Clear? Object will replace water. Object will replace water. Clear? That's it. It is a Archimedes principle. Now I am moving forward. Density. I was saying density. Now in front of you, density. Relative density. Density is what? Mass upon volume. Volume is just space. And what is the mass of an object? Both will be matter. Both will be definition of a density. Mass of that object and what is the space of that object will be known as density. Unit of what density is what? Kg upon meter square. Okay, kg upon meter cube, because cube is coming because of we have a volume, that's why. And what is the relative density? Is there any difference between density and relative density? I think it should be a difference. So relative density is equal to density of a substance upon density of a water. No unit. No unit. Density of a substance, okay, upon density of water. If density of substance is more, but density of water is normal, then what will happen? Of course, that object will sink, will not float, will sink. That object will sink because of density of substance is more and density of water is normal. Now density of a substance is less, but density of water is normal. Now what will happen? That object will float. Rather than sinking, that object will float because of density of that substance is less. That's why it happens in nature. It is a truth. Clear? Do you understand? Again, some day we will take this lecture as a revision. Okay, don't worry. So, should we move forward? Of course, yes. Summary and key formulas for gravitational is what? If as we were, it came. No, I would not say it came from Newton's law, but it is related to Newton's law. Yes, this is what I can say. F is equal to we used to read what F is equal to m mass a solution. Same here. M, okay, but you can see this is a different Z. Okay, this is formula to calculate a gravitational force. Weight m multiple Z, and for pressure thrust upon area, for density mass upon volume. For Archimedes principle, Buoyancy force, weight of weight of a displaced fluid, weight of a displaced fluid. This were formula. By using this formula, we calculate whatever we want to calculate. We have some of the applications, so let's answer one by one. Who discovered the law of gravitation? So I don't know. I don't know because we didn't see this case in this lecture during the lecture. What is the value of a gravitational constant? I think this should be value of a gravitational constant. So next, which quantity remains constant everywhere? So constant, not thrust, not pressure, not weight, but only mass. Okay, this is done. This is also done. Next is unit of pressure is what? Pascal. Yes, unit of pressure is Pascal. We measure pressure in Pascal. Acceleration due to gravity on Earth is what? I think 9.8 meter per second square. Okay, here I am forgetting. Beyonce force acts in which direction? So I think in upward direction. In upward direction. Downward direction is for gravitation. Relative density has okay, relative as we saw relative density has no unit. Yes, no unit. Which instrument measures weight? Which? A spring balance. A spring balance measures weight. Now next is what causes tides on Earth? So I think moon's gravity. Moon's gravity tides on Earth. Formula for gravitation force is what? F is equal to Z into M1 into M2 upon R square. This is a formula for gravitation force. The end. We are done. We are done. That's all in this slide. Next slide. In the next slide, I will be taking something else chapter. So finally, we have done. We have completed this discussion, which name was gravitational.